So we're finally getting to that point where we multiply matrices together. We multiplied by a scalar. That was super easy. Very intuitive. See, I remember that word today. This is not quite as intuitive. Okay, if I ask you to multiply these matrices together, you'd probably look at them and you're like, I might have an idea of what to do, but I really doubt that you would get it. Again, it's not that difficult. It's just a little pattern you got to remember. That's all it is. Okay, so first of all, we can't multiply like any two matrices together. Just like when you add matrices, what had to be true about the two matrices if you were to add them together? They had to be the same exact dimensions. That is not necessarily true about multiplying matrices. Okay, so there is a little trick to figuring out if you can multiply these matrices to begin with. Sometimes you can't even multiply them together. There's nothing you can do. All right, so let's take a look. So if I had matrix A, and matrix A was, let's say, a 2 by 3, and you wanted to multiply it by matrix B, and matrix B was, let's say, a 3 by 5. Okay, here's a little trick. Everybody watching? Here's a little trick to see. It's not a trick. It's just a method. It's a way to see if you can actually multiply them together. You got to go through this first. Before they ask you to multiply it together, check this out first, okay? And you got to write down whatever the dimensions are for your two matrices, and then watch this one. This one right here and that one right there have to be the same number. See what I did? All right. So if I had a 2 by 3 and a 3 by 5, okay, these two right here, the columns on the first one have to be the same number of rows on the second one. Okay? Everybody with me? Because this is rows, columns, rows, columns. So this column and this row have to be the same number, have the same number of elements in it. Everybody okay with that? All right. That's the first thing that you need to do in order to multiply them together. So we're going to do a little example just to test to see if we can multiply these together or not. So I'm going to give you 3 matrices. So it takes a second to write all this stuff down. But here's matrix A, and it's 12, 43, 56, 27. We're really not going to do anything with these numbers, to tell you the truth. These could be any numbers, but it's a 2 by 2 matrix, all right? And B is 15, 92, 0. That's 19, 7, and 31. So that's matrix B. Matrix C, it's a 3 by 3. So it's 9, 51, and 8, 55, 76, and 14, 29, and again, it really doesn't matter what the numbers are. I could have kept it 21, and 11, and 63. Okay. All right, so what we're going to do is we are going to see, they give you 4 problems on this example, okay? They give you A, B, C, and D. A, B, C, and D. And they just, you're not actually going to multiply them, okay? You're just going to see if you could multiply them together, all right? And what little test do you do to see if you can multiply them together? You do this little test right there. The columns of the first one, the rows of the second one. If they're the same, then you can multiply them. If they're not the same, then you can't multiply them. If you cannot multiply it, they say it's undefined. That's what the word we're going to write if you cannot multiply them together. So how do we check? Well, first of all, what are we multiplying? So part A, you're multiplying A times B. Part B, you're multiplying AC, BC, and BA. All right, so all we're trying to do is figure out, are you able to multiply? And it does matter. We're gonna see this later on in the lesson. It does matter what order you multiply them in. So, for instance, we'll wait till we get to it. It's called the commutative property. Do you remember the commutative property? We'll talk about that later. I'm not going to do it now because we got a spot for it. But A, B, if I multiply those together, I'm not actually going to try to multiply them. I'm not going to do anything. All I'm going to do is look at the dimensions. What are the dimensions of A? 2 by 2. okay? And we're going to multiply it by B. What is B? 2 by 3. So can you multiply those matrices? Yeah, because what do? You look at those two right there, all right? And one other thing this tells you is the dimensions of the answer to your multiplication, all right? So the answer to your multiplication are these two on the ends, okay? So this is going to give you a 2 by 3 matrix, all right? Notice, they're not the same dimensions, are they? One's 2 by 2, the other's 2 by 3, but you can multiply them together, okay? Even though they're not the same dimensions. They don't have to be the same dimensions, all right? But the columns on the first one and the rows on the second one have to be the same. And it also tells you what type of matrix, what the dimensions of the matrix are going to be for the answer to that multiplication problem. All right, so that's kind of cool. Doing this tells you two things. First of all, it tells you if you can multiply them, all right? And if you can multiply them, it tells you the dimensions of that matrix. What about AC? Well, again, A was what? 2 by 2? And what is C? 3 by 3. So, can you multiply them together? No, you cannot, because this is a 2, this is a 3. They are not the same, so you cannot multiply them together. What did we say we write down for an answer? It's undefined, okay? That just looks better than saying you can't multiply them together, all right? So we just say undefined. Make sense? Let's do BC. It's pretty easy so far. So again, what's the dimension for B? 2 by 3. And you're going to multiply it by C, which is a 3 by 3. Can you multiply them together? Yep, you look right there. If those two numbers are the same, you can multiply them together. Well, what's the answer going to look like? What kind of matrix? Is it? You say 3 by 3? 2 by 3. Okay, I thought you said 3. All right, so it's a 2 by 3 matrix again. Now, they're not always going to be 2 by 3 matrices, but in this particular case, they are. All right, what about BA? So we're looking A, but it's an A. All right, so B again is what? 2 by 3. And multiplied by A, which is a 2 by 2. Can you multiply them together? Nope, because this one and this one are not the same, so you would say it's undefined. They may ask you that for a couple problems at the beginning, all right, but they're not going to ask you that all the time. But it's super important. Every time you multiply them together, I always do this. I always do that, all right, because I want to make sure that I can multiply them together, because they could slip in a couple problems where you can't multiply them together. And then you go through all this work, and then you finally figure out, wait a minute, this ain't going to work, all right? So do this first, and it also is nice because it tells you how many rows, how many columns, all right? Yes? You can. It doesn't matter, all right? Just write undefined is fine, but yeah, you can do that. It means the same thing. All right, everybody good? All right, let's move on. Flip my page here. All right, now we're actually going to multiply something together, all right? But I'm not going to put actual numbers in there. I'm going to put some letters in there, show you how to do it generally, and then we'll stick some numbers in there, and then we'll actually do one with real numbers where we actually do some multiplication, okay? So this is matrix multiplication. Let's write that down. Matrix multiplication. All right. What I'm going to do is I'm going to go A, B, C, D. And obviously, these represent any numbers at all. All right. And I'm going to multiply it by E, F, G, and H. Now, they're both what we call square matrices, right? 2 by 2s. Can you only multiply 2 by 2 matrices together? No. Okay, but as long as, watch, if this, do it right here. This is 2 by 2. We're multiplying it by another 2 by 2. So this right there tells us what? What is that? That you can multiply them together. That's right. What does this 2 on the end and this 2 on the end tell you? That your answer is going to be a 2 by 2 matrix. Okay? Everybody with me so far? All right. So again, like I said, I do that for every matrix that I use for multiplication. I do that little test right there. So here is how you multiply them together. Everybody watching? what I do is I take the first row and I multiply each element by the first column, and I do them two at a time. So I'm going to go A times E, and then before I go B times G, I'm going to add those two together. All right, so I'm taking the sum of the products of the elements. Do you hear that? All right, so what's that going to look like? So I'll put my little bracket right there. So it's going to be A times E. Everybody see that? So I do the first one times this one right here. Okay, that's the first step I do. And then I put a plus, and then I do the second one, right? The B and the G. Everybody with me? All right, so I take the first row, first column, and then I multiply each element, okay? Well, not every single one together, but the first one's together, the second one's together. All right, we'll say it like that. Okay? Now, we just move this little bar over here. So I'm going to take that same exact row and multiply by the second column. And where I'm going to put it over here. No. Nope. Like I said, you keep the same row, but you multiply it by the other column. All right? Keep the same row, then do it by the other column. And you're going to put that over here to the right. Since this row goes from left to right, every time we multiply this row by all these columns, then we're going to keep on going this way. Everybody hear that? All right, so now what do we do? This is going to be what? AF. Whoops, let's change this to white. Just to be consistent. So it's going to be AF plus what? A, the first one and the first one, then the second one and the second one. So it's going to be what? BH. Now it's 2 by 2, so I got my 2 on the top, right? Then I'm going to have 2 down here. So now what do? Yeah, I move this one down like that, and I'm going to take this one back to where I started. You getting the pattern? Okay, yeah. After you do it a while, it becomes second nature to you. So now we're going to do basically the same thing, but we're going to start down here. So now I'm going to take this and go what? C times E. So I'm going to go CE plus what? DG. Good. Again, this is not intuitive, is it? There's no way you could have sat here. You could have sat here for hours and days and weeks and years and probably never come up with this. All right? I don't know, maybe years you might have. Okay, but yeah, it's not intuitive. All right, so we got that one, and now what do? We take that same row, and then we multiply it by the other column. All right, so we take the C again. So we're going to go this time what? CF plus, go to the next number, DH. Okay? So you don't repeat it. You don't go CFCH. Everybody see that? That's a common mistake people make. You go CF and then the next one, DH. All right? So if you look at this, look what you got. You got A, B. Let's see. What was I going to do? Well, look at the up and down ones. See the E and the E are on top of each other, the G and the G, F and F, H and H. Everybody see that? Okay, so I've got AB, and then I've got, AB and AB. That's what I was looking for. I don't know why I didn't see that. AB right here, AB right here. What's this one? C and C, and then D and D. All right, so you can kind of see the pattern. I don't really look at it that way. I like to do that. What I do is I use my fingers. Everybody watching. Now I'm going to be backwards. I'll go like this. Let me remove my microphone. Here's what I usually do. I usually go like this, like that. Okay, and that kind of keeps. That's how I like to look at it. I go across here, down here. So I go boom like this. Then my left hand stays here. My right hand goes in the next column, and I go like that. Got it? Then I start over on the second row. Then I go like this, and then I go like this. All right, so sometimes that's kind of helpful. All right, I can't really show that with my fingers on the video, but the red lines kind of help, though, didn't they? All right. So now you are finally ready to your first matrix multiplication problem. Sure you are. It's not the same dimensions, but it's the same idea. Okay, it's the same exact idea. So I'm just going to write it out. A times B. So we've got 2. That's way too big. 2, 4, 0, 1, 3, 5. This is matrix A, and I'm going to multiply it by matrix B. So this is 3, 4, 5, 2, 1, 0. All right. Now you're ready to do what we just did and do your multiplication. So first of all, let's see if this is a problem where you could actually multiply together. So what are my dimensions for this first one? 2 by 3. And this one, 3 by 2. Can you do it? Yep, 3 by that 3 and that 3. And so this is going to end up as being a what? 2 by 2 matrix. Okay, so 2 across the top, 2 across the bottom. We good? All right. You want to try it yourself? Yeah, why don't you do that? Okay, I'll get you started. All right, and I'll let you do it by yourself. So
My pencil don't function.
It don't function? They teach you that at Tall Oaks, Delaware Valley? I don't think so. They'd have a heart attack if they heard you here saying that. Wouldn't they? Right, I could believe that. I'm going over to Tall Oaks today, or Delaware Valley. Talk to Mr. Rao, because he teaches over there. So we've been keeping in touch. Like, we text each other every once in a while. Hey, how's things going? And all that kind of stuff. All right. So there we go. So you do this one and this one. So it's going to be what? 2 times 3 plus what? 4 times 5 plus 0 times 1. Okay? Then after you do that, then you bring this over, if I can. There you go. And then you're going to go, I'll let you do the rest. You do it. Give you a minute or two. I think I'll pause the recording. Pause. There we go. It's the first time I've paused a video. All right, so let's do this. So it's a 2 by 2, right? Sometimes I don't even draw these boxes at first, okay, because I want to just make sure they fit in there. But let's do it. So across the top, down the column, all right? So what do I got? 2 times 3 is 6. And then what? 4 times 5, which is 20, right? We add it. Okay, we're adding every one of these. And then I go 0 times 1, which is 0. I'll add those up in my next step. Okay? So let's do the top right one. So we stay with the first row. Now we move over to the second column. So I go 2 times 4, which is 8. 4 times 2, it's another 8. And then 0 times 0, which is a 0. Now I drop down. Okay, I'm dropping down to the second row, so I'm dropping down to the second row here. Everybody see that? All right, so now we go to the second row, first column. So it's 1 times 3, and then it's 3 times 5, 15, and then it's 5 times 1. Okay, stay with the second row, move over to the second column now. 1 times 4, and then 3 times 2, and then 5 times 0. And now you just add them up. 26, 16, 23, and 10.
That is so cool, isn't it? That's so neat.
And there you go. That's your answer. Did you guys get that on your own?
Yes.
Yeah. Again, after a while, they get a little easier.
They get easier.
Well, no, they get easier because you know what you're doing. Right. This one, I tell you what, just for the sake of time, it says refer to the football data at the beginning of the chapter. All right. So they have a little chart when you first open up this. When you first open up the chapter or the lesson, I don't know which one. maybe it's the lesson. You're going to see something about football. Do you see it? What page is that? Zanaya, what page is that on? 156? Okay. So there's some data there, but what I'm going to do is this. I'm just going to set it up as a multiplication right off the bat. I'm not going to go look at the data and all that kind of thing and then write them separately. I'm just going to multiply them together. So what do we got? We got 2, 2, 2, 0. We got 0, 3, 2, 1. We got 3, 4, 4, 0. Okay? So that's our one thing. They call that T, all right? Matrix T. And we're going to multiply it by matrix V. All right? And the V is just, it's a 4 by 1 matrix. 3, 6, 1, 2. All right, that's all taken from, again, that chart at the beginning of the lesson. Is the beginning of the lesson or chapter? Probably the lesson, right? Okay. So we want to multiply those together. First of all, let's see if we can multiply them together. What are your dimensions here? 3 by 4. And this is it 1 by? It's a 4 by. 1, 2, 3, 4. 4 rows. 4 by what? 1. Can you multiply them? Yes, because they're the same number. What are your dimensions after you multiply them? 3 by 1. All right, so it's going to be 3 what? 3 rows and 1 column. So it's going to be skinny, isn't it? Okay, so it's going to be right here. Actually, I'm going to widen it out because we have to do some, your answer will be skinny like that. But we're going to have to put a lot of addition in here, so I'll spread it out a little bit. All right, so what do? We go across the first row and down this column. All right, we only have 1 column to do, so we're just going to go this row times this column, this row times a column, this row times a column. All right, so let's see what we can do. So 2 times 3, that's 6, plus another 6, plus another 6, plus a what? A 0. This one, 0, plus, it's 3 times 6, which is 18, plus 2 times 1. Now you got to drop down. You got to keep dropping down. This is the third one. This is the third one. So it's 2 times 1, which is 2. And then it's 1 times what? 2, which is 2. Right? I did that right, didn't I? I did that right, didn't I? Yeah. It's not? Oh, wow. I sure didn't. Why did I do that? That was silly. Okay, good. I'm glad you said something. That's right. And then 2 times 6, which is 12. And then 2 times 1, which is 2. And then 0. Got that part right anyway. Good. Thanks for pointing that out. I would have messed it all up. All right, let's do the third one now. So 3 times what? 3, which is 9. And then 4 times 6, which is 24. 4 times 1, which is 4. And then 0 times 2, which is 0. All right. We'll just slide this over a little bit. Okay. And now we can put equals, and now we can do it. I don't know, 12 times 2 is what? 14 and 6 is 20. This is 4 and 18, which is 22. This is 28 and 9, which is what? 37. And there you go. That is how you do it. All right? All right, got another thing to do. Everybody's good so far, right? Yeah. If not, go back and look. No, we're doing the whole thing. I'm just giving you... Come on, we got 15 minutes. What are you going to do? Just sit around and do nothing? Come on. No. All right. Oh, wow. Crying. You guys are crying. It's so cute. All right, here we go. Is matrix multiplication commutative? Did I spell it right? Commutative. Yes. Is it commutative? Is matrix multiplication commutative? Well, what does commutative mean? It means that A times B is equal to what? B times A. Shh. Okay, we've had our little fun, had our little cry. All right, now we're back to work. All right, this is commutative property. All right, so that means like 3 times 2 is the same exact thing as 2 times 3. So there is commutative property with addition and with multiplication, with regular numbers, real numbers. But is there a commutative property with matrices? All right, well, we already did one. If you look back to example 2, do you remember example 2? Do you have that in your notes? Example 2. We multiplied A times B, and we got 26, 16, 23, and 10. Do you remember that? Yes? Okay. So the question is matrix multiplication? Hunter, I'm up here. Is matrix multiplication commutative? So is B times A, is matrix B times matrix A equal to this as well? Well, let's just check and see. All right. We'll come back to that. B is, this right here is the 3, 4, 5, 2, 1, 0. So it's 3, 4, 5, 2, 1, 0. That was the B in example 2. Okay. The A was 2, 4, 0 and 1, 3, 5. Now in example 2, we multiplied this one first, didn't we? Okay, this one was first, this one was second. So let's see if we get the same thing. And then we could decide if matrix multiplication is commutative or not. So let's give it a shot. First of all, what are the dimensions of this? 3 by 2. And this one? 2 by 3. So can you multiply them together is my first question. Yeah, absolutely. And if we multiply them together, what kind of dimensions are we going to get? A 3 by 3, all right? I'll just leave that bracket open. I don't know how far I'm going to have to write. Okay, so let's go through it. Everybody ready? So we're going to go the first row, first column. So 3 times 2, 6. And then 4 times 1 is 4. Then we go, same row, different columns now. So 3 times 4, 12. And then 4 times 3, which is also 12. All right. By the way, if all I wanted to do was just to see if it was commutative or not, I really don't even have to go through this stuff. I'm going to in a second just to get some extra practice. But what was my dimension of my B times A? It was 3 by 3. What was the answer to A times B? What were the dimensions to my A times B? It was a 2 by 2. Is there any way that they're going to be the same then? No. All right, so is there commutative property with matrix multiplication? No, there's not. So really, that's all I needed to do. And again, just to save some time, I'm not going to go through the rest of that. You can do the rest of that yourself if you wanted to. I'll just tell you what it is. It comes out to 10, 24. So if you want to practice it, just for extra practice, feel free. Here's what you would get. 10 and then 240, 240. So that is not, that right there is not the same as that, is it? Obviously not, okay? So you cannot switch the order. It definitely matters what order you multiply things in, all right? That's the whole key to that problem that they gave us right there, okay? We wanted to figure that out. All right, here's another thing. This is not going to take too long, hopefully. There's also a thing called the multiplicative identity. All right, now there's also an additive identity. What's an additive identity? Like if I wanted, what am I going to add to this to keep it the same, to keep it identical? A 0, right? That's additive identity. Everybody with me on that? What's multiplicative identity? What do I multiply this by in order to get the same thing? A 1. Okay, so multiplying by a 1 is multiplicative identity. But there's also multiplicative identity to matrices. All right, I'll show you what it looks like. A multiplicative identity is always going to be a square matrix, which means it's going to be a 2 by 2, 3 by 3, 4 by 4, and so on. Okay, so here's what the first multiplicative identity looks like. I'll call it capital IY identity, right? So here's what it is. It's 1, 0, 0, 1, which means if I multiply any other 2 by 2 matrix by 1, 0, 0, 1, I'm going to get the same exact matrix that I started with. You hear what I just said? So if I take some other matrix, a 2 by 2 matrix, okay, and I multiply it by this right here, I'm going to end up with the same exact matrix. All right? And we could keep going. If it was a 3 by 3, remember, the identity matrices are always square matrices. Okay, it's always 2 by 2, 3 by 3, 4 by 4, okay, for an identity. So this would be 1, 0, 0, 0, 1, 0, 0, 0, 1, if you had a 3 by 3 matrix. Okay, so that's your identity for a second order or 2 by 2. This would be a third order, 3 by 3. Those would be the matrices. Can I prove it? No. I don't know. It's been like that all afternoon. Last period, I got it from this side, I got it from that side, and they were just as loud, and we were all just looking at each other like, what in the world's going on here? Yeah. So anyway, we're going to keep going. We're going to keep going. Now, here's this. Listen, come on, pay attention. Focus, focus. Stop. No, I'm focusing. Okay, you can focus. All right, watch this. A times I. I is the identity matrix. A is just some random matrix, okay? Is this, put a question mark, if I multiply this by an identity matrix, is it the same as this? And you're probably thinking, no way, because that means commutative property. And we just said there's no commutative property, right? But with an identity matrix, there is, all right? And let's just show you super quick, all right? So let's say A is 3, negative 1, 8, 12. So what am I going to do to it? I'm going to multiply it by a what? By what? A times what? Identity matrix. That's right. What is the identity matrix if it's 2 by 2? It's 1, 0, 0, 1. So let's do that kind of quick. 3 times 1 is 3, and then 3 times 0 is 0. 3 times 0 is 0, plus negative 1 times 1 is negative 1. Okay? Let's do this one. 8 times 1 is 8, plus 12 times 0 is 0. 8 times 0 is 0, plus 12 times 1 is 12. Let's see what we get. Boom, boom, equals, what's that? 3, negative 1, 8, and then 12. So is that truly an identity matrix? Okay, Gio, you asked me to prove it. Basically, that just did it. Okay, it just proved that if I multiply it by this, I get the same exact thing. Okay, what about this? Remember I put a question mark right here? Let's see if that works. Let's go I times A. So we're going to go 1, 0, 0, 1. And then multiply it by that same matrix, 3, negative 1, 8, and 12. All right, so here we go. Let's do it. 1 times 3, 3. 0 times 8, 0. It's just a 3. All right, 1 times negative 1, which is what? Negative 1. 0 times 12 is just a 0. Everybody with me? 0 times 3 is 0. And then 1 times 8 is 8. 0 times negative 1 is 0. 1 times 12 is 12. Do we get the same thing? Yes. So is there commutative property with an identity? Yes, there is, okay? So there we go. One more thing, and we don't even really have to do any arithmetic with this. I mentioned this to you maybe yesterday, day before, I can't remember. Remember I said, remember when you had to solve those simultaneous equations like 3x plus 2y equals 7, and then 2x minus 5y equals 10, and you had to use substitution elimination. Remember what I said, I think it was yesterday, didn't I say that? That we're going to actually do that with matrices. So today we're not actually going to do it. Okay, we got some other things to learn before we do it. But what we're going to do is we're just going to set it up. All right, so let me give you, I'll just do one of these. I got two of them written down, but I'll just do one of them because of time. So what if I had this? And you've seen this before. You've solved this kind of stuff before. So what we're going to do is we're going to set it up. We're not actually going to solve it today. Eventually we will, but not today. We're going to set it up into matrices. And then after we do this, that's it. We are finished for today. But we're not finished now. Don't pack stuff up. All right? I can see with me even looking at the screen. All right, so here we go. What we want to do is we want to set this up in matrix form. Okay? So what we're going to do, you kind of see a matrix here, don't you? Don't you kind of see that? Yep. But these are being multiplied, aren't they? So what we're going to do is we're just going to take the coefficients. What's the coefficient mean? The number that's out in front of the variable. That's right. So I'm going to write just, as a matrix, I'm going to write down just the coefficients. So what's this going to be? Let's go across. So 3 what? 1, negative 4. Okay, let's just stop right there. Let's go to the next one. What's this going to be? 2, 3, 4. The next one? 1, negative 1, good, and 2. So we're going to make that into a matrix. Since this is multiplied by x, this is times y, this is times z, we're going to put times x, y, and z. If you go through that whole matrix thing, 3 times x, 1 times y, negative 4 times z, it works, doesn't it? Okay? What do you think that's going to equal? Another matrix. It's going to be what? Negative 22, 32, and 16. Okay? So this is just where we start. Okay? We got a couple things to do first before we actually solve for x, y, and z. But we eventually will get to that. We're actually going to get to the point where we solve for x, y, and z with these matrices. Which means we have to get rid of this. We got to put this on the other side, don't we? So how do you usually put something on the other side if it's being multiplied? If it's being multiplied, you divide. But we don't really divide matrices. We multiply by the inverse. Multiply by the inverse, okay? So there's a thing to finding the inverse, all right? And before we find the inverse, you got to find something else, which is called the determinant. I don't know if it's the next lesson or not. Do I have determinant? No, it's probably next week. So we got to learn how to do the determinant, and then you can do the inverse, and then once we learn that, then you can solve for x, y, and z with matrices. Okay? All right. Look at that. We got done. A couple minutes to spare in the class. That wasn't too bad, was it? So how do you feel about multiplying matrices? Not as bad as what you thought, right? Okay, we'll see.